In this video, we will be writing an API which will generate a blog post complete with title, content, and tags and store it into the database. We will specify a post endpoint for generating posts and a get endpoint for listing the posts. We will use FastAPI Python framework as our backend, Langchain framework to help us with the AI part, and MongoDB to store the post data. Let's go! Let's get started with our project by initializing a virtual environment using the uv-init command. I will create a main.py file and a directory called app where other parts of the program will be stored, such as the database manager and Pydantic models and so on. I'm going to import and install FastAPI, which is the backend framework that we are going to use. Next, I will import a python.env package, which will load values from an env file. Only do this if you haven't already exported your OpenAI API key in your environment. I will now initialize a FastAPI app and build our first endpoint. Let's simply return the word hello to see if everything works as it should. At the end of the script, I will import and run uvicorn, which is a web server used by FastAPI, so that when I execute the main.py file, the server will start as well. Let's run it and see if it works fine by calling our endpoint. Okay, looks great. In the next step, I am going to create a new Python file called simplydb. We will store our database manager with all the necessary functions, such as reading from the database and saving data. I will start by importing Motor, an asynchronous MongoDB driver that we can use to communicate with the database using async await keywords. Other choice would be to use PyMongo, but this is a synchronous driver, which means we can't await any of the blocking methods and would have to use a built-in thread pool manager instead. Let's create a new class called AsyncDBManager. In the class constructor, we initialize client by passing the MongoDB URI as the host parameter. We haven't booted up Mongo yet, but since we will be running it locally, we will use the localhost address and the default port with no further parameters. One thing we must not forget is to pass TLS value as false, otherwise we would receive an SSL error when trying to connect. Obviously, this is only for development purposes. In production, you will have to connect to the database securely. Next, initialize database variable with database name and collection name. In this case, the database name will be blog and collection will be posts. Let's fire up our Mongo database. I'm going to open Docker and look into the images section. Here you should see Mongo image already downloaded. If you don't see it, it's because you haven't downloaded the image yet. Run Docker pull Mongo command to grab the image. In this example, I'm going to use MongoDB, but you can obviously use any other database, SQL or NoSQL, depending on your preferences. FastAPI is very flexible and works with any database. The reason I am choosing Mongo is because it allows us to directly insert the generated post as a JSON object into the database without any further conversion to rows and columns. I am going to select the Mongo image and click Run. This is going to start a new container and run Mongo inside of it. Next, I will specify the port on which the service will be listening. Make sure this port is not already occupied by another service. Now all I need to do is click Run, and our database is running. We can connect to it using MongoDB Compass tool. I am going to create a new database and collection to store our data. If you skip this step, it should work fine, because Mongo will create those for you if they are missing. Here is our newly created collection. Now, I will initialize the database and store the object in a variable called DB. Let's import the DB object from the app module so we can call the database function from our main py file. Make sure that in your app folder you have an empty init.py file, so you don't have problems importing from the folder. This file is necessary for Python to recognize the app directory as a package, so we can import from it. Now I will create a new file called creator.do.py inside of the app folder. This file will house a function, which when called, will return a newly generated blog post as a Python dictionary object. I will install the required dependencies and import response schema, structured output parser, prompt template, and chat OpenAI tools. This new function will be called createBlogPost and will take topic as a parameter so that you can specify which topic to cover in the blog post. Now we need to generate a prompt for the AI to instruct it exactly what it needs to do for us. We use the response schemas to draw a blueprint of how the response should look like each time. We certainly want a blog title, content, and then some tags. AI should follow this schema exactly as it is written, but keep in mind that with some models, especially the smaller ones, you might encounter some occasional issues when the model doesn't follow the schema properly and fails validation. We will proceed to create an output parser, which will parse the output into our specified response schema. Then we call the getFormatInstructions function to get the instruction. Now we will write a system prompt to the AI model, telling it to assist with our request as best as it can. Then give it the instructions we created, followed by the question variable, which will be blog prompt string we created earlier. This is more or less a slightly more advanced way of coming up with a long paragraph of text outlining our instruction, followed by the request. Next, we define out AI model. I will use the GPT-4o model, which is an advanced model that should not struggle with such a task and generate a very engaging and realistic blog post for us. We set the temperature very high so that the model varies in its generations and uses rich vocabulary to write the blog posts. Now we need to define the chain. Using the Langchain expression language, we chain the prompt, model, and output parser together in one variable. On this variable, we can then call the invoke method to communicate with our LLM. Make sure to call invoke method asynchronously and await it so that it isn't blocking the server running loop. We will pass the blog prompt string as the question variable and create some basic error handling just in case the invocation process fails during any stage. I will define a dictionary variable called result and populate it with the response data, which will contain all the things that we specified earlier. I will transform the tags to a list by splitting them by the comma character and store the title and content in their respective fields. Then, I will return the result. In the main file, I will import the function we just created along with JSON response from FastAPI, using which we can easily return a response to the client with specified content and status code. I'm going to edit the existing get endpoint we have created, and in it, I will call the create blog post method with topic about green tea health benefits so we can see that everything works as expected. Since this method is asynchronous, we must not forget to await it. I will do some basic error handling in case this function fails to execute and return a 500 server response if something goes wrong. Let's test our endpoint in Postman. Okay, that looks great. We have the tags as a list, title, and content, just like we wanted. In the second part of this project, we will update the endpoint so that any client can call the API and receive a blog post about any topic they want. We will utilize Pydantic to validate the responses and save the data to MongoDB. We will also add a new endpoint for listing existing blog posts and rendering them as HTML template. Thanks for watching, and don't forget to subscribe.